Well, hello everybody. Welcome to Blue Marble Science. How stupid can you be? Well, I'll tell you, SC Montreal has taken up the challenge. Warning. Severe facial and monitor damage alert is in effect. Get out those oven mitts. Push the monitors back out of punching range. Let's light this dumpster fire and have some fun.
So that's what started all this, Blue. The Cavendish detecting the Haiti thing.
Haiti thing? Huh? Yeah, I don't know why that's confusing to anybody. I don't know why it wouldn't.
Well, for starters, there was how many earthquakes on that day?
Oh, I don't know. Probably hundreds of them.
And how is it that you were able to distinguish that earthquake from the rest of them?
Well, quite obviously, that event occurred, I think, at about it was 8:30 here in this time zone. So, midway through the day, if you go by international time. So I don't know, on a normal spread of data, I would think half the earthquakes happened before that time and half after that time. Obviously, none of the earthquakes that happened after it could have been it, right? And then you're left with the ones that occurred before it. Well, there was only one large magnitude earthquake that day. Hold on there, cowboy. You forgot about the earthquake in the Aleutian Islands that happened a little more than 30 minutes before the earthquake in Haiti, but its strength was about 1/3 the strength of the earthquake in Haiti, and its epicenter is almost 3 times as far away. So that one didn't seem to match up. It was a 7.2, I think was the last number I saw. That one in Haiti, which occurred at 8:29 in just a few seconds, I think, is when the event started down there. And at 8:38 or 8:39, somewhere right around that time period, that's when we saw the torsion balance start reacting to it. So it's just really a fairly simple process. You've got one major event that would have been strong enough that we could have felt it here where I'm located. And then it has to match up time-wise, which it does. That's the only way you can come to the conclusion.
So are you saying that you've checked all the earthquakes that happened in that day? For example, there could have been some closer by,
yeah,
less of a magnitude that could have registered, and how did you eliminate that exactly?
Yeah, we did. We checked. There were none close by. None of any significance. Nothing that we would have seen.
So you checked and you verified all the other earthquakes of the day? Really, Blue?
Really, SE? Have you checked have you checked it?
Where can you check something like that, by the way? Could you tell me which website records it?
I can get a list of it. You can Google it. Current seismic activity.
Current seismic activity for any part of the world.
Yeah, you can Google it. This is usgs.gov. Let me see if I can show you how you do this. You'll know you're at the right place because it'll say USGS up here. If you go down right here to search earthquake catalog, let's try that. Search earthquake catalog. Magnitude custom. Well, I don't want a minimum of 2.5. I want the minimum to be 1.5. Nah, let's go look. 0.5, how's that? Now I got a better idea. Minus 0.5. Bet you didn't know you could have negative seismic values. Anyway, you can. Now, do I want the past 7 days? No, I want custom. What I want is 8:14. Let me change that to 14. And I want to change this one to 14 also. So we just get that one day. That's the only one we're interested in, right? 8/14. Okay. Geographic region, the world. Search. Whoa, look at that. Looks like we're seeing the Earth many times, so let's zoom in a little. There's South America and South America and South America. Let's zoom in a little bit. And maybe not that much. So that's got easily the entire Earth on it right there. I'll zoom in one more time. I kind of like the other view better. Let's just use this one. Because we're going to see that a lot of the activity on that day is centered in this region and up here around Alaska and here in the Caribbean. So, let's see what they're giving us. You'll notice that each one of these tells you what the magnitude of the earthquake was, the date of it. They're all going to say 8/14. And the time in UTC. This first one is the very last one in the day. 23:53 and 43 seconds UTC. South Sandwich Islands region. And if I click on it, you see the little blue dot come up down here. And it tells you it's a magnitude 5. Okay. Well, I'll let you in on a little secret. There's really no point in looking at earthquakes that occur after the time you see the event. So we can ignore these times until we get down to the time that we saw what we saw, which was about 12:38 UTC. So that's going to be midday down around in here somewhere. Let's go down here and see where we are. Back up a little bit. There's the event that we think we were witnessing, the one in Haiti. So here's 12:38. Certainly nothing above this point makes any difference to us. Here's 12:38, 12:34, and it's a 3.3 in Perryville, Alaska. Again, let's see which one that is. It's right there. That's 5,800 miles away from here, or 5,800 kilometers. So there's no point in looking at that one. All right. And there's the 7.2 that happened at 12:29 and 8 seconds UTC. Okay. We think that's the one it was. So let's go back prior to that time, and let's say an hour. So let's go back to 11:30 more or less. Let's see where that would be. There's 11:43, 11:34. So we could start down in here somewhere. Don't really care where. Here's a magnitude 0.7 in California. Obviously not it. 2.5 in Alaska. 2.2 in California. 1.5 California. A 2.6 in Puerto Rico. These are all way too small for us to see them. 4.6, that's a pretty decent sized little earthquake. But it's in the South Sandwich Islands region, way down here. Way down there in the southern Atlantic Ocean. So I don't think that's it. There's a 1 and a 1.2. That one's in Oklahoma. Let's see where that is, right there. That's in Oklahoma. But it's an hour before we actually saw the event, so that can't be it. Far too close. 2.3 in Alaska, 1.4 in Nevada. Again, the timing just won't work with any of these. 1.2, 1.3 in Alaska, 1.2 in Carlsbad, California, And then we have a 6.9 in Perry, southeast of Perryville, Alaska, right there. That's in the Aleutians, or off the coast, actually. And it happened at 11:57 and 43 seconds. Now that's roughly 42 minutes before we saw the event. 42 minutes. Let's keep that in mind, because this has got possibilities, right? It's a 6.9 though. And while we're at it, let's think about this. It's a 6.9, and the earthquake that happened in Haiti was a 7.2. So let's see. Again, this is USGS. You can tell it says USGS on it. How much bigger is a magnitude 7.2 than a 6.9? Well, the difference is 0.3, and a 7.2 is 1.995 times bigger than a 6.9, but it is 2.8 times stronger in terms of energy release. So depending on which way you guys want to look at it, you could say that the earthquake in Haiti was at least twice as large as the one that occurred up here in Alaska. Let's remember that. So we'll go on up. Here's a 2.7. Let me close that. Here's a 3.6 in Perryville, Alaska again. Here's one, a 5.4 in the Mid-Atlantic Ridge, way over here in the center of the Atlantic Ocean. That's probably not it either, because that's not all that much further away than Haiti is. Yet it's about 30 minutes before we actually saw the event. Another one in the Sandwich Islands. Here's some 2.7s, and these are all. Here's a real small one in Nevada. Most of these are up around the Aleutian Islands, or they're down there in the Sandwich Islands. Not seeing really anything that makes any sense. Very small ones. And then finally, we get to the one in Haiti. That's a magnitude 7.2. It occurred at 12:29:08 UTC. And that's the one we think we saw. We think it was this one and not this one up here in Alaska, because this one is only half, even in the most conservative way you can look at it, it's half the magnitude of this monster down here, but it's about 2.5 times as far away. It was 42 minutes between the time this thing struck and the time we saw the event here in Tennessee, but it only took 10 minutes from the time we saw this one strike till the time that we saw something here in Tennessee. And that's not 4 times as far away. That's only about 2.5 times as far. So that's the reason that we think that this is the one we were looking at. So is everybody clear? This is how you can look up earthquake data, seismic data for the entire world for any time frame you want to look at. And there were a lot of earthquakes that day, by the way. 513 of them that were magnitude minus 0.5 and greater. I'm talking to SE if you don't mind.
Okay.
Okay, Blue. Let's say I was to give you that, which I find highly improbable that you checked everyone. But let's say I was to give you that.
Wait a minute. Wait. Why would I check every? What do you mean checked everyone, SE? There was only one that occurred within 10 minutes or so of us seeing what happened to the torsion balance. Only one that would have been a magnitude large enough to have caused us to be able to see anything. How many more? Why do I need to check any more than that?
Well, there could have been someone closer by, right?
There were none.
With a smaller magnitude, no? that you may have not
Okay, do you
deemed
have
like.
do you, all right? Do you have one that you'd like to look at?
No, I'm just asking you if you eliminated all the other earthquakes and how you came to the conclusion that out of hundreds of earthquakes that day, only that one registered on your thing.
No, see, what you're actually doing is calling me a liar. I think everybody heard what you said. I heard what you said. I just didn't react to it. Yeah, see, that was the only one of any significant magnitude anywhere near on that day. And the timing of it is far too coincidental to just be a coincidence.
Okay, so are you saying now in the future, if we have another earthquake of that magnitude, your apparatus will be able to pick it up?
Not necessarily. You could have
Why
another.
not?
Well, it's not just a matter of the magnitude of the earthquake. It's the proximity of the earthquake to where you are. Now, that one was fairly distant from here, about 2,200 kilometers.
Yeah, that's pretty far away, I would say, no?
Well, right. What if it's on the other side of the planet? No, I don't think
Okay,
I'm
so
going to see
if
it.
we were to go back now, your apparatus is operational for how long, would you say?
Oh, I've been operating it since December last year, or this year. Well, last year, yeah.
Okay, so I would venture to say, now I could be wrong about this, and I won't even say it, I'll just say it as a question. If we were to check the seismic activity going back that long, do you think we'd find something that would be able to register within the vicinity of what you said?
I don't know.
How far would you say your apparatus could detect, first of all? We know up to 2,200. Would you say further than that, or would you say that's the limit?
Let's be extremely clear about what I'm saying to you. I'm not an expert in seismology, do not claim to be, have never made any claims along those lines. Okay? I rely on the input that I get from people who are experts in that field, guys like PhD Tony. The very first thing I did after that happened was send Tony a DM, and I can show it to you, where I said simply,
He's the one that came up with that idea then, Blue? I gather?
No, he's not the one that came up with that idea. He's not. The only reason I was asking Tony is because that's the only thing that seemed to make any sense. Some sort of seismic activity would have caused the balance to do what it did. I was very curious about it. And if you listen to the video when it was happening live, you'll understand that I didn't make any claims. Not one. Now, following the event, I sent a message to Tony, and I heard from other people too, but Tony in particular. And I said, this is what happened. This is what we saw. Take a look at the video. Does this make any sense? Please tell me that I'm out of my mind. That Cavendish could not possibly ever have detected that. Tony came back and said, no, that's absolutely what it detected. The timing matches.
Okay, so you're going by timing. It just happened to happen at that particular time.
That's how I can't help when it. I didn't cause it to happen. SC, you can go verify it for yourself. The earthquake happened at 8:29 in Haiti, and that's the same time zone as Knoxville, Tennessee. I didn't see anything at 8:29 or 8:30 or 8:31, but at 8:38, I think I see the very first little bobble in it. And by 8:40, you see the torsion balance swinging slightly. That's exactly.
I'm just saying. I'm just throwing this out here now.
That's exactly the length of time that people who are experts in the field of seismology tell me it would have taken the S waves to make it from Haiti to Knoxville, Tennessee.
Yeah, obviously, it would have to be the surface wave. Yeah.
No, those are called secondary waves.
Is it possible? Sorry?
They're secondary, but okay, whatever. called the
The
surface
secondary
activity.
waves, not the primary. Okay. Now, I put this to you. Is it possible that precisely at that time, big old crane could have been passing by your house, like next door, and caused that bump?
Never seen it before.
Exactly, or since.
Or since. Wow. The incredulity is thick enough to walk on, isn't it? Hey, thanks for making my point, SC. 46 tests that were videoed, most of them were live streamed. 45 tests, each one about 4 hours in duration, without this disturbance. One test with a disturbance, and very coincidentally, a large earthquake about 10 minutes before. I can't imagine why this is hard to understand.
My point is, if we go back the past, how many months you said you had your
Yeah.
apparatus, and we were to and check the seismic activity.
Yeah.
Do you think we'd find anything of substance? And if so, why hasn't your apparatus recorded that?
I don't run that thing 24 hours a day, 7 days a week, Montreal. I will tell you that in the, probably several hundred hours that we have actually had the thing on live stream, you can't find it doing that. The only time you find it doing that is when I accidentally bump it.
Yeah, but I'm saying, couldn't a truck have passed by a big heavy crane, for example, and hit a bump that you wouldn't be able to hear or feel, but your apparatus picked up? Isn't that possible?
SC, I don't live in the ghetto. And then there are no big heavy trucks.
You lived in a ghetto?
The heaviest thing that drives up and down the street in front of my house is an SUV. In fact, the heaviest
So we
thing,
ruled out any big heavy equipment. How about a garbage truck? Do garbage trucks pass by your house?
At 8 o'clock on a Saturday morning? No.
Okay, we're ruling stuff out.
You just don't get it, do you? You don't.
It was Sunday morning.
It was a Sunday morning? I forget
Or
what
Sunday.
day it was.
Saturday or Sunday, I forgot now.
All right, now that we've exhausted that line of questioning, the real elephant in the room is this, Blue. If your device is designed to measure mass attracting mass, am I correct in that?
Yeah. That's what a torsion balance is
And
for.
sorry, go ahead.
That's what a torsion balance is for. Yes.
Perfect. That was my next question. So if we just shown that your torsion bar has not eliminated a certain variable, a very important one, doesn't that throw your whole experiment, like, I hate to say because you put a lot of work in it, doesn't that throw that out the window?
Nope, not a bit. It had no effect on the accuracy of the measurement of the gravitational constant. That type of motion is not
how
what
we
we're
just
measuring.
shown that at an earthquake.
That type of motion is not the motion we're measuring, SC.
Yeah, but the torsion bar you just said yourself got affected.
Wait, it wiggled up and down as far as I remember.
Yeah,
left to right.
that's the opposite. That's the wrong direction. We're measuring the torque in the wire, the twist in it, not the forward and backward swinging of the torsion balance.
But it did affect the torsion balance itself, right? That thing, the main thing
Doesn't
that
affect,
is supposed to be, independent of everything, right?
It does not affect the amount of deflection of the torsion balance. It only caused the laser to bobble up and down as the entire thing was swinging like a gravity pendulum. That's what causes that.
Actually, it didn't affect the torsion balance. It affected the room with the torsion balance.
I didn't understand.
Oh my.
The torsion
affected the room?
is the room was moving, not the balance.
See, this is shaky coming in here. I mean, if you want to...
That's how seismograph works. You have a heavy weight that doesn't move because it has inertia, and everything around it moves.
Right.
No.
Blue, I think you need to have a talk with him there. He just ruined your whole experiment.
He did not,
Oh, go ahead.
SC. Your inability to understand the experiment is not my problem.
Okay, if that's what you say.
Oh yeah, that's exactly
Did I
what
just
said.
hear Chaiki or Blue? Just one question. That the whole room moved, but the weight,
Yeah,
right?
yeah. And Blue agreed with him.
Those mirrors are sitting on the Earth, and the Earth is very noisy. It jiggles everything. And you want to make sure that the thing that jiggles the mirrors is only the gravitational wave. So we use all sorts of tricks. And I'll show you one of the tricks. Here's one of the tricks. What we do is we suspend the mirrors from a pendulum. Here's a sort of demonstration pendulum. And here's the mirror, and my hand will be the ground motion. And you notice if I move it very slowly or at low frequencies, the pendulum follows me. It follows the ground motion completely. Now let me wiggle it fast, and you'll notice the pendulum stands still while I'm wiggling. That's the basis of the idea.
And the same thing can happen here. Cavendish looks a lot like LIGO in some respects. We've got those two weights that are hanging from wires from the torsion balance. The torsion balance itself is hanging from a wire. The case can move. The torsion balance doesn't move very much, but it will move a little bit. The weights will pretty much stand still. The mirror, on the other hand, is what's moving. It's just moving toward us slightly and away from us slightly. That's all that's happening. You guys really ought to study physics. Newton covered this thing called inertia. That's what we're dealing with. That's what pendulums do.
No, let them say yes or no. I had a simple question.
That's how a seismometer works. You realize that, right?
Oh my fuck.
Oh, do you or do you not? Do you understand how a seismometer works?
Yeah, it records every movement, whatever it is.
Okay, well then tell me how it works though. How does it do that?
I just said, like, did you
It
not
records
hear me?
every movement, and that's telling me how. Oh yeah, I've got a great feeling that you know exactly how it works.
Yeah.
Okay.
So you don't see the paradox here, Blue, that you build a device that's supposed to be independent of everything.
Don't make me call you a clown, SC. Well, okay, you're a clown. Cavendish is protected from magnetic influence simply by the fact that it's built out of diamagnetic material. It's isolated from electrostatic influence because it's got a Faraday cage built into it. It's isolated from rapid temperature changes because it's in a controlled atmosphere. But it is sitting on a table, and the table is sitting on concrete, and the concrete is sitting on the ground. Now, if the earth decides to shake, that's going to shake the concrete. The concrete's going to shake the table, and the table is going to shake Cavendish. If you're too thick to figure that out, I don't know what to tell you.
And then it detects a earthquake. You don't see the paradox in that, sir?
No, I don't. I think you're hung up on the word paradox. I think you ought to look it up and see what it means. Everything to you is a
Well,
paradox.
choose another
SC.
word then that makes you feel more comfortable.
Everything is a paradox to you for some reason, SC, and this is not a paradox. No,
Well, maybe I used the wrong word, but, you know, doesn't that seem strange to you?
No, it doesn't. No, it doesn't. It doesn't account. Nothing accounts for me accidentally bumping it either, does it? When I've accidentally bumped it and the thing does exactly what it did, that's the same sort of motion that an earthquake would cause. You're essentially bumping the cabinet. When I've done that accidentally, what does it do? Well, I mean, what do you do about that? You can throw the data out if you like.
You're making my point for me, Blue.
You can throw the data out if you like.
I told you a truck could have passed by and caused that at 8 o'clock while you were sleeping. And you said, no, the only thing that passes by is a 4x4. I mean,
Yeah.
You know really what passes, everything that passes by your house, really?
I
Blue?
was sitting right there. Yes, I do, on a Sunday. I think it was a Sunday morning. Yeah, and I know there were no garbage trucks or any other kind of trucks, big trucks going up and down this residential street I live on, which is about a quarter of a mile away from the nearest large road.
Maybe you were walking by the apparatus and you bumped onto it at 8 o'clock on Sunday?
Why don't you watch the
Been in the
video?
garage
Why
doing
don't you
something?
watch the fucking video, and you'll see that didn't happen. I
That
was
was a
live
joke.
online at the time.
That was a joke.
I was live online at the time. No, I didn't bump it. That's what was confusing to me. If I had bumped it, I would have known exactly what caused it. And it would not have been a mystery. And I would have simply said, okay, that's not good, shouldn't have done that. But it has really been shown many times to have no effect on the measurement that we're making, which is the twist, the deflection of the beam. That lateral left and right motion of the laser is not affected by that. It just makes it bobble up and down a little bit. That's just the swing.
So something that was designed for sideways detection, you're saying now detected something up and down. Am I getting this clear?
When you upset it, it can do that. It will show that, but it doesn't change the reading that you're getting in terms of the amount of deflection that you're seeing. It's the opposite direction.
So
it's
you don't think I have
to
any
it.
reason of concern here?
No,
I'm
I don't
just
think you do. I don't
making
think you know
shit
what you're
up.
talking about. I think you're talking out of your as usual, S.E.
I was
And
expecting
you know
you to
are.
say that.
And you know you are.
Absolutely not, Blue. You got a thing that it's supposed to detect gravity, right? Mass attracting mass, sideways motion, and then you claim that it's meant for that. Then you claim that it's up and down motion.
I stand a better chance of teaching this chicken how to deal blackjack than I do of teaching S.E. Montreal how the pendulum in a grandfather clock works.
And that the room is shaking. Like, you got to make up your mind here.
I don't have to make my mind up about a thing, S.E. I've told you what happened, and I've told you what it does. It's quite easy to see it. You can see it on the on the vernier scale. You can see that the entire beam is the entire torsion balance is rocking left and right, not twisting.
I thought you said
Rocking.
up and down. The beam was going up and down, I thought you said.
If you'll
Just tie a knot in it.
for a second, I'll explain it to you. And when the beam rocks a little bit, that changes the angle that the mirror is sitting at. And that results in an up and down motion of the laser, not a left and right motion, an up and down motion.
Why are you so angry, Blue? Why are you so angry on your own server?
Oh dear. S.E. Montreal and What's Up have climbed to the very pinnacle of Mount Dunning-Kruger and set up a permanent encampment. Hey, thanks for watching. Hope you guys enjoyed it. Don't forget the like and subscribe button. And shout out to the patrons and PayPals. Thanks for everything you guys do. And we'll catch you on the next one.